Hi students, today we are going to see about energy losses in fluid mechanics, and myself K. Anandu, Department of Agriculture Engineering, Nanda Engineering College. Okay, so what is energy loss? So it may also called as a head loss, and it is defined as potential energy that is converted into kinetic energy. Okay, so do you know about potential energy and kinetic energy? Potential energy is a stable energy, and kinetic energy is a flow energy, right? So if a water or liquid a change its states from stable position to a flow position, the velocity or the pressure gets changed. So that we are considered as a energy loss. Okay. So there are two energy losses in during the flow. So first one is major losses and second one is minor losses. Okay, so we can calculate major loss and minor losses by using Bernoulli's equation. Here I have mentioned. So P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus HL. So the HL is called as a head loss. Okay, due to it may be a major loss or a minor loss. Okay. So what is major losses? Major loss is the energy or head loss due to overcome the frictional resistance between the pipe wall and fluid. So simply, so major loss occurs due to friction within a pipe. For example, if you are walking on the ground, the friction is created, right? So that's why our slippers get weird and damaged. So here the friction loss is considering as a major loss. Okay, so we can calculate the friction loss by using the formula from Darcy-Weisbach equation. HF equal to FL V square divided by 2GD. Okay, and what is minor loss? So minor loss is the energy loss or head loss due to change in pipe geometry or change in velocity of flowing fluid. So the minor losses occurs due to change of section of the pipe or bend or other interruptions. Okay, so there are so many losses in so many classifications in minor losses. The energy loss due to sudden expansion, and energy loss is due to sudden contraction, energy loss due to bend in pipe, and energy loss due to various pipe fittings. Also the energy loss at the entrance of pipe and the energy loss at the exit of the pipe. Okay, so first we will see about energy loss due to sudden expansion. So see the diagram. The horizontal pipe diameter or the size of the pipe get increased. Okay, so if the water gets flow through a pipe, the flow area of the pipe get increased. Okay, so results in change of velocity or pressure. Here the velocity get reduced, the pressure get increased in the section 2. So what will happen? So what are the energy loss due to sudden contraction? If the water get flows through a pipe, the flow area of the pipe get reduced. Okay, so results in change of pressure and also results in change of velocity. So here the pressure get reduced, the velocity get increased. So these are the we are considering as a energy losses, like it's a minor losses. Okay, how we can find the value of energy losses, minor losses? Due to sudden expansion, HL equal to or HE, okay, equal to V1 minus V2 the whole square divided by 2G. And due to sudden contraction, for sudden contraction, HC equal to or HL equal to 0.5 into V2 square divided by 2G. Okay, so energy loss due to bend in pipe. If the water gets flow through a pipe or a horizontal pipe, the direction of the flow gets suddenly changed. Okay, I have mentioned the arrow mark in the diagram. So due to the change of direction, the velocity get suddenly reduced. So this is also considered as a minor losses. So how we can find the minor loss due to bend in pipe? HL equal to K into V square divided by 2G. Also, the energy loss due to various pipe fittings and entrance of the pipe and exit of the pipe, let me see in the next video. Okay, I will explain this concept in next videos. Now we can see the problem based on minor losses. Okay, so the rate of flow of water through a horizontal pipe is 0.25 meter cube per second. The diameter of the pipe, which is 200 mm, is suddenly enlarged. Okay, suddenly enlarged or suddenly expanded to 400 mm. So the horizontal pipe, the section 1 is 200 mm, but for section 2 is suddenly enlarged, right? So section 2 diameter is 400 mm, and the pressure intensity in the smaller pipe, okay, is 11.77 Newton per centimeter square. These are the values given. So now we are going to determine, first one is loss of head due to sudden enlargement. Second, the pressure intensity in the larger pipe, and third one is power loss due to enlargement. Okay, so first write the given data. What are the given values? Okay, so they given discharge, right, or rate of flow 0.25 meter cube per second, and diameter of the pipe section 1, at section 1 D1 equal to 200 mm. I just converted mm into a meter, so 0.2 meter, and diameter of pipe at section 2 D2 equal to 400 mm, because it suddenly increased, no, the size of the pipe increased, right, from 200 to 400 mm. So therefore 0.4 meter. And pressure intensity in smaller pipe P1 they given, right, so 11.77 to Newton per centimeter square. So I have converted into centimeter to meter, so therefore 11.77 into 10 to the power of 4 Newton per meter square. Okay, what are the finding values, finding things? So loss of head and pressure at large in pipe and power lost. So how we can find the value of loss of head due to sudden enlargement? We know the formula for sudden enlargement, right? HE equal to V1 minus V2 the whole square divided by 2G. Here V1 and V2 are the unknown values. So now we have to find the value of V1 and V2. So how we can find the value of V1, V2, velocity 1 and 2? We know that the formula from continuity equation, Q equal to A1 into V1 equal to A2 into V2, right? So we can find the velocity equal to Q divided by A1 and V2 equal to Q divided by A2. We know the value of Q, right, but we don't know the value of A1 and A2. If we find the value of A1 and A2, area 1, area 2, we can easily find the value of V1. So we know the formula for area. A1 equal to pi by 4 d1 square, A2 equal to pi by 4 d2 square. So A1 equal to, we get 0.0314 meter square, A2 equal to 0.126 meter square, right? If you are substituting the areas in velocity formula, we can find the value of V1 and V2. So V1 equal to 7.96 meter per second and V2 equal to 1.99 meter per second. So substitute the V1 and V2 values in head loss formula. So He equal to V1 minus V2 the whole square divided by 2G, right? G equal to acceleration due to gravity. We know the known value for G, right? 9.81 meter per second square. So finally we got the value of He equal to 1.816 meter. So this is the loss of head due to sudden enlargement value. Okay, then after that we have to find the pressure at larger pipe, right, for section 2, right? Okay, so we can find the value of pressure from Bernoulli's equation. We know the formula for Bernoulli's equation. P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2, plus we have to add loss of head due to sudden enlargement, He. So here we know the value of P1, V1, V2 and rho g. Rho is density of water, right? 1000. So G 9.81. So here you just assume Z1 equal to Z2. So the Z1 and Z2, if the Z1 is and Z2 is equal, it cancel, right? Okay, substitute the known values in the Bernoulli's equation. Finally we can get the value of pressure at section 2. It equal to 12.95 into 10 to the power of 4 Newton per meter square. And finally we have to find power loss, right? So what is the formula for finding power loss? Rho g q He divided by 1000 in kilowatt. So what is the value for rho, or density of water, 1000 into G 9.81 into Q, they given, right? 0.25 into He, we found this one 1.816 divided by 1000. So if we solve this, we got the value of 4.45 kilowatt. Okay friends, thank you. Okay students, thank you.